How do you keep liquid out of your compressor? The refrigerant is going to enter this line here as a low pressure vapor, all right? And then it's going to go through this compressor and it's going to get compressed. And it's going to exit as a high pressure vapor, all right? So it came in as a low pressure vapor. It's going to get compressed and leave as a high pressure vapor. And then that condenser that sits around this compressor is where the refrigerant's going to go through. And it's going to eject the heat, essentially. That's why that fan is there, to pull air in across those coils to the center and eject out the top. So that hot air you feel is the hot air coming out of your home. Now, in that process of traveling through that condenser coil, it's going to turn into a liquid, all right? And then it's going to travel on to the coil. I had an earlier video where I talked about an evaporator coil. How it gets into the coil is a TXV, thermal expansion valve. This is a TXV up close. I showed in an earlier video one that was installed, but this is the up close TXV. This here is what we call a sensing bulb. This actually has refrigerant in it. The same refrigerant that your system has in it is inside this bulb, all right? And it's gonna go to the top of this TXV. And you're gonna have refrigerant coming in and out of this TXV. When it enters, it's going to be metered, meaning based on the demand is going to determine how much the demand for cooling. So if it's high demand, it's a hot house, hot building, it's going to push a lot of refrigerant into the evaporator coil. All right. As that demand increases, it will start to close and less will flow in. So think of this as a fuel injector for your car. You push down on that pedal to the floor, those injectors are opening all the way up and pushing tons of fuel into that engine. Start to let off, it starts to close, it reduces the amount going in. Same concept here, all right? Now, this can get fouled up. How can this get fouled up? Well, there's several ways. One of the biggest ways is dirt and debris getting into this. Could get into this or your capillary tubes, but for fouling the TXV, it gets into here, causes clogs and backups and restricted flow, things like that. This bulb, if this bulb is not placed in the correct area, if it's not connected at all, it's not going to be able to do the proper measurement to know what demand is being placed on the system to communicate to this TXV how much refrigerant to let in. I'm giving this in very basic layman's terms because you don't have to diagnose your system. You just have to understand some of the things that are going on with it. So this TXV is critical, a real important component on your system. It cannot get fouled. Dirt and debris needs to stay out of it. And if it is fouled, a technician can diagnose it by taking the proper measurements, refrigerant readings, and determine that this is the culprit or most likely the culprit, and it can be replaced. All right. Now, how do you keep dirt and debris out of your system? Well, number one, every system should have a filter dryer. This is a filter dryer. Think of this as the same thing as an oil filter in your car. Refrigerant flows through this, and this has material in it that filters out anything that shouldn't be in there. This is critical component to be on your system. Now, what's important is you can't have a lot of these on your system. Don't think more is better because they get clogged up and they start restricting your system. If one starts to get clogged up, it's caught a lot of debris, starts to cause a restriction. Again, a technician can diagnose that, and then you just change out this filter. But this is very critical. The other thing that's really important to know, if you ever have to have your system worked on, if they've got to change a compressor, if they got to change service valves, which are on the condenser, if they got to change a TXV, if it has a leak that they repair, essentially, if they have to open up your system, the refrigerant loop, for any reason, this needs to be changed. That's how you reduce contaminants. Think of this as IV antibiotics after surgery. It's going to make sure any contaminants that had gotten into the system or were missed are filtered. Probably overlooked more times than I'd like to think about. Lastly, this is really important. In fact, if you have anybody work on your system, if you get a new system, you want to ask, do you flow nitrogen when you braze? Now, the only acceptable answer is yes. How do you know if they do it? Well, while they're doing their work, go out and observe it. You'll see a nitrogen tank, you'll see it connected to the system, and you'll see them flowing nitrogen. Ask them, hey, can I see when you braze? Can I see the nitrogen? Can I see how that works? You have every right to. This is your system, and if it's not done correctly, it's going to cause you problems. I guarantee it. And that's why on replacement, always make sure they're flowing nitrogen. Why? This is copper line, and you can see this is an outside braze joint, okay? And you can see this is oxidized from the oxygen, so the sulfos is what we use to braze this. So you can see all of this here, right? Well, that's what happens. That's a normal process of brazing. Now, what does it do on the inside? Well, here's one, same thing. These are a little ugly because we had to cut them and get them opened up, but here's a braze joint on copper. I hope you can see this, but without the nitrogen flowing, there's oxygen present. And what you have is all of this oxidation on the inside of this copper. Now, this flakes will travel along and get caught up in this TXV. Yes, hopefully this will catch some of it. Typically, it ends up here, and you end up with issues and bad TXVs not long after an install. God forbid it gets into here. You don't want that. Now, let me show you what it looks like when you flow nitrogen. This one, nitrogen, very similar outside. And if you can see, the inside is clean, right? No oxidation, no debris. This is why you always flow nitrogen. Not flowing nitrogen will wreak havoc on your system. So very, very important when someone works on your system, if they're going to open the system, they're going to replace the filter dryer. They're going to braze with nitrogen. And then the other step is they're going to pull a vacuum. And pulling a vacuum pulls all the non-condensables and everything like that out of the system. Very important step. So inside this compressor, inside this motor, there's an internal overload safety. An internal overload safety is typically two dissimilar metals that when they heat, they bend apart and the system shuts off. There's no longer current is able to flow through this. Now, if the technician doesn't know how to diagnose this properly, then they're going to misdiagnose your system as fail. It shouldn't happen. It does happen. Important to know if you have a commercial structure and you have three-phase power, or in the rare instances you come across three-phase on a residential, how you check the windings on a system that uses three-phase power is totally different. So very important that you understand that. The technician obviously understands. But you're going to measure these windings. I won't go into what windings you measure and whatnot. But basically, you measure all three of them, and it'll tell you if this is out on internal overload. If this is out on internal overload, it needs to cool. And as it cools, those dissimilar metals will connect and power will be restored to the compressor. What's really important is why did it go out on internal overload? And there's several reasons that could happen. We just had a system that the compressor would keep going out on internal overload, and it eventually took the compressor out. The compressor finally died. Replaced the compressor, and we were still having an issue. Technician stayed for several hours, basically just hanging out at the condenser, taking measurements, checking things, and we finally got the system to reproduce the issue. And it had to do with the condenser fan motor. It was a two-stage condenser fan motor, had a low and a high, but that was the issue that took out the compressor. So we were able to get the system fixed. It's under warranty. Now, though, a good technician is going to say, why did the condenser fan motor have issues? Is it simply a mechanical piece of equipment that had its issues, or is there something else causing it?